This is SpaceTime Series 28, Episode 43, for broadcast on the 9th of April 2025. Coming up on SpaceTime, why does the planet Venus have so many volcanoes? The European Space Agency shuts down the Gaia spacecraft for good, and the first manned mission to orbit above the Earth's poles. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study suggests that convections in its planetary crust could explain why Venus has so many volcanoes. Venus is Earth's sister planet. Both worlds are about the same size and age. They both evolved in the same part of the solar system, out of the same materials, at the same time, and under similar conditions. But while the Earth has a life-sustaining environment, Venus is a hellish world with a runaway greenhouse effect. Its surface is scorchingly hot, with average temperatures of 462 degrees Celsius. That's hot enough to melt lead. It has thick, opaque, planet-shrouding rain clouds. But the rain that falls isn't water, it's droplets of metal-eating sulfuric acid. Scientists have seen what look like snow clouds on some of Venus's tall mountain ranges, but the snow isn't frozen water, it's actually metallic. And those suffocating clouds on Venus are so heavy, they crush the planet's rich carbon dioxide-based atmosphere, acting like the lid on a pressure cooker, and giving the planet a surface pressure some 92 times greater than the average sea level surface pressure on Earth. The surface of Venus is dominated by thousands of volcanic structures, more than any other planet in the solar system. And now a new study suggests the planet may even be more geologically active near its surface than previously thought. New calculations suggest that the planet's outer crust may be constantly churning, an unexpected phenomenon called convection that could help explain many of the volcanoes and other features of the Venusian landscape. One of the study's authors, Slava Solomatov from Washington University in St. Louis, says nobody considered the possibility of convection in the crust of Venus before. But Solomatov's calculations suggest that convection is possible, and perhaps even likely. Now, if true, the findings, reported in the journal Physics of Earth and Planetary Interiors, give scientists new insights into the evolution of this planet. Convection occurs as heated material rises towards a planet's surface and cooler materials sink, creating a constant conveyor belt. Now, on Earth, convection deep in the mantle provides the energy that drives plate tectonics. Solomatov says the Earth's crust, which is about 40 kilometres thick under the continents and about 6 kilometres thick under the ocean basins, is too thin and too cool to support this type of convection. But he suspects that the crust of Venus just might have the right thickness, somewhere between 30 and 90 kilometres, depending on location, composition and temperature, to keep that conveyor belt running. Now, to test his hypothesis, Solomatov and colleagues applied new dynamic theories which suggest that Venus's crust could support convection. Last year, Solomatov used a similar approach to determine that convection likely didn't happen in the mantle of the planet Mercury. That's because it's simply too small and has already cooled significantly since its formation 4.6 billion years ago. Venus, on the other hand, is much bigger, therefore it can retain more heat both inside and out. He says surface temperatures and its volcanoes and other surface features all show clear signs of melting. Scientists have long wondered how heat from the planet's interior could be transferred to the surface, and convection of the crust could be a likely missing mechanism. Convection near the surface could also influence the type and placement of volcanoes on the Venusian surface. Back in 2023, scientists published an atlas of Venusian volcanoes based on radar images from NASA's Magellan mission in the early 1990s. Solomatov now wants to combine his mathematical modelling with the observations of Venus's surface to better understand the planet's geology. Now, if convection is occurring as he suspects, some areas of the crust should be warmer and less dense than others, and those differences would be detectable using high-resolution gravity measurements. This is SpaceTime. Still to come, the European Space Agency shuts down the Gaia spacecraft for good, and SpaceX launches its first manned mission to orbit the Earth's poles. All that and more still to come on SpaceTime. The European Space Agency has finally powered down its Gaia spacecraft. Gaia has spent more than a decade gathering data on the stars of the Milky Way galaxy. But on March the 27th, Gaia's mission control team at the ESA's European Space Operations Centre in Darmstadt, Germany, switched off the spacecraft subsystems and sent the probe into a retirement orbit around the Sun. Launched back in 2013, Gaia has transformed science's understanding of the cosmos. It's precisely mapped the positions, distances, motions and properties of nearly 2 billion stars and other celestial objects. This has provided the largest and most precise multidimensional map of the galaxy ever created, revealing its structure and evolution in unprecedented detail. Gaia's uncovered evidence of past galactic mergers. It's identified new star clusters. It's contributed to the discovery of exoplanets and black holes. It's mapped millions of quasars and galaxies, and it's tracked hundreds of thousands of asteroids and comets. The missions also enabled the creation of the best visualization of how our galaxy might really look to an outside observer. Gaia project scientist Johannes Zalman from ESA says the spacecraft's extensive data releases are a unique treasure trove for astronomical research, which influences almost all disciplines in astronomy. He says Data Release 4, which is planned for 2026, and the final Gaia Legacy catalogues, planned for release no earlier than the end of 2030, will continue shaping astronomy's understanding of the cosmos for decades to come. Gaia has far exceeded its planned lifetime of 5 years, and its fuel reserves are now dwindling, hence the decision to end the mission. And the Gaia team carefully considered how best to dispose of the spacecraft in line with ESA's efforts to responsibly end its missions. They wanted to find a way to prevent Gaia from drifting back towards its former home near the scientifically valuable Lagrange L2 position on the opposite side of the Earth from the Sun. So after a lot of planning, a trajectory was established which allowed one final burn of Gaia's thrusters to move the spacecraft away from L2 and into a stable retirement orbit around the Sun that'll minimise the chances of it coming to within 10 million kilometres of the Earth for at least the next century. Once safely in its new orbit, mission managers deactivated and switched off the spacecraft's instruments and subsystems one by one before deliberately corrupting its onboard software. The communication subsystem and the central computer were the last to be deactivated. Of course, though Gaia itself has now gone silent, its contributions to astronomy will continue to shape research for decades to come. Its vast and expanding data archive remains a treasure trove for scientists, refining their knowledge of galactic archaeology, stellar evolution, exoplanets and much more. A workhorse of galactic exploration, Gaia has charted the maps that future explorers will rely on to make new discoveries. For example, the star trackers on ESA's Euclid spacecraft use Gaia data to precisely orient the probe. And ESA's upcoming Plato mission will explore exoplanets around stars characterized by Gaia, and may follow up on new exoplanetary systems discovered by Gaia. This report on the many, many achievements of Gaia from ESA TV.
The Gaia mission has transformed our understanding of the Milky Way. Launched in 2013, the Gaia Space Telescope set out to map our galaxy with precision. Since then, Gaia has delivered one breakthrough after another. Gaia has made more than 3 trillion observations of 2 billion stars, asteroids, and distant galaxies. These observations have allowed researchers to peer deep into the Milky Way's past, present, and future. Gaia has redefined our view of the Milky Way's structure. While we knew it was a spiral, Gaia revealed new details on the number and arrangement of its arms. This has reshaped our understanding of its structure and composition. It's also helped estimate the Milky Way's mass, which has been difficult to determine, with much of it hidden in an invisible dark matter halo. But thanks to Gaia's astrometry, we can now peek into this vast hidden region and uncover its true extent. Gaia has also revealed how nearby dwarf galaxies and the large Magellanic Cloud are shaping its evolution. As Gaia unravels the Milky Way's past, it reveals a complex galactic family tree. One of the most groundbreaking discoveries is the Gaia Sausage Enceladus merger, a cosmic collision 10 billion years ago. This merger involved the absorption of a smaller galaxy into the Milky Way, and its remnants can still be seen today. Gaia has also shed new light on the Sagittarius dwarf galaxy, which has been colliding with the Milky Way for billions of years. These repeated impacts have warped our galaxy's disk, and more surprisingly, may have even triggered the formation of the Sun 4.6 billion years ago. These interactions are still ongoing and continue to shape the movement of stars within the Milky Way. Gaia has also mapped star-forming regions in stunning detail. Just 500 light-years from the Sun, which is relatively close in astronomical distances, these regions offer key insights into how stars are born. Gaia isn't just mapping the present, it's uncovering the Milky Way's deep past. Two ancient star streams, Shakti and Shiva, merged with the Milky Way over 12 billion years ago before it fully formed. Gaia's precision lets us trace their orbits, revealing how the first stars took shape long before our Sun was born. The history of the Milky Way is one of constant growth through collision. Over billions of years, smaller galaxies have merged with our own, leaving behind traces of these cosmic encounters. One key discovery is the Virgo radial merger, which happened just 2.7 billion years ago, much later than once thought. This highlights just how dynamic our galaxy's evolution truly is. In an exciting breakthrough, Gaia revealed the presence of potential moons orbiting more than 350 asteroids previously thought to be solitary. By detecting tiny wobbles in their orbits, Gaia uncovered a hidden population of binary asteroids, nearly doubling their known population. One of Gaia's most unexpected findings was discovering stellar mass black holes closer to Earth than seen before. This new population of black holes also exist in wider orbits with companion stars, challenging our understanding of how these massive objects form. Gaia also unearthed a sleeping giant, a dormant black hole in the constellation Aquila, 33 times the mass of our Sun. This sparked new questions about the formation and behavior of such massive black holes. As Gaia moves towards its passivation, it has stopped observing the stars, but its discoveries will shape astronomy for generations. 2 massive data releases are still to come, refining our knowledge of the Milky Way and unlocking new cosmic mysteries. Gaia's legacy is one of profound discovery, and its data will inspire scientists to continue exploring our place in the universe.
This is SpaceTime. Still to come, SpaceX launches the first manned mission to orbit above the Earth's poles, and later in the science report, warnings that agriculture is likely to push antibiotic use on livestock by a further 29% over the next 15 years. All that and more still to come on SpaceTime. SpaceX has launched the first manned mission to undertake a polar orbit. The historic mission launched aboard a Falcon 9 rocket from Pad 39A at the Kennedy Space Center at the Cape Canaveral Space Force Base in Florida. The plan to undertake a polar orbit and consequently a 90-degree inclination was a first.
Stage 1 LOX load is complete.
All right, we've got a good LOX load on first
Dragon is
stage.
in terminal count and is on internal power.
And we've got the confirmation Dragon has gone internal power, coming down from the crew back to the Dragon team here in the Mission Control Center.
Dragon, SpaceX, go for launch.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, ignition, and liftoff.
Copy, 1 Alpha.
Vehicles pitching downrange.
Stage 1 propulsion is nominal.
T plus 35 seconds into the From 2 mission, the first ever human spaceflight mission to cover the poles.
And we are throttling down the engines on the first
Power
stage.
telemetry nominal.
On the first stage vehicle 4.
Stage 1, throttle down.
Oh, it's perfect timing with these callouts. We throttled down the engines
Max Q.
for max Q, and there's max Q. It's the maximum dynamic pressure that the vehicle
Falcon
sees
9
on
is
ascent.
supersonic.
We're preparing to throttle back up on first stage Merlin engines.
Stage 1, throttle out.
1 Bravo.
That means if there was a need for an abort with the first stage now emptying itself of propellant, Dragon would fly a different profile than if, say, right off the pad we had initially.
MVAC chill is underway.
We're beginning to chill the second stage engine in preparation for its ignition.
We also have a few events that are going to happen back to back. We'll have MECO stage separation and second stage engine ignition. MECO is main engine cutoff. That's where we will shut down all of those 9 engines on the first stage vehicle to slow
Stage 1, throttle down. MECO. Stage separation confirmed.
Stage 2.
Copy, stage 2.
We've also started the boost back burn on the first stage.
Dragon, SpaceX, trajectory nominal.
Dragon, copy.
Coming up in a couple of minutes, we'll have the entry burn on the first stage, which is currently making its way back down to Earth, and we did perform a boost back burn on this one.
Yeah, we did a 1-engine boost back burn. We didn't have, normally when you launch to the east or northeast in a crew mission, you take advantage of the Earth's rotational velocity, but in this case, we're pretty much going straight south, and so you don't get that eastward velocity. So the first stage needed to use a little more propellant to get the crew up into the right position for stage separation. So we can't bring the first stage all the way back to land like we might do on an ISS mission. So instead, we're going to land on the drone ship, but not as far south as we would normally do.
Dragon,
if this
SpaceX,
was
trajectory nominal.
something like a Starlink mission.
The entry burn has begun.
Copy. Nominal.
Entry burn did complete. We didn't hear any callouts, but we do have a green screen here. We have a good entry burn. Second stage continuing to head towards the separation orbit. First stage heading to the drone ship.
Stage 2, FTS has safed.
We are expecting the landing burn on the first stage to occur in about 20 seconds from now. That'll just be a single engine burn on the vehicle. Once again, the M1D engines have about 190,000 pounds of thrust, which is just enough to slow the vehicle down just in time for landing.
Copy, Panama.
It's another abort call out on the second stage. You run a space station, you hear it called Shannon. That tells you where you can reach if there's a problem right now. First stage, landing burn has begun. Legs are deployed, and touchdown after 6 flights. But we heard the terminal guidance call. We've essentially reached the altitude. Now we're working the angular momentum of the orbit. So we're going to listen in. We're just seconds away from shutdown. And about less than a minute after that, we should have Dragon separation from the second stage.
MVAC shutdown.
Dragon, SpaceX, nominal orbit insertion.
And great news there. We heard the call out for nominal orbital
Dragon,
insertion.
copy. Nominal.
Dragon copies nominal.
The crew conducted 22 science experiments during the mission, including tests monitoring glucose regulation, a study of spaceflight on women's reproductive health, and Australian research into growing mushrooms in microgravity as a tasty, high-nutrition space food supplement. The experiment referred to as the mushroom. Another Australian connection to the mission is 62-year-old South Australian polar explorer Eric Phillips, who was one of the 4 crew members on the flight.
I'm an Australian polar adventurer, explorer. I've skied 4 new routes to the South Pole. These are expeditions that I've planned myself. I've looked at satellite imagery of these glaciers that have never been traversed before, and I'm going to have the opportunity as we fly over Antarctica and see those routes from above. We know that photographs of the Arctic and Antarctica are available on Google Earth and through satellite imagery, but to see them from orbit may reveal things about these 2 areas, the Antarctic and the Arctic, that we have previously not known.
This was also the 6th launch for the same Falcon 9 booster and the 4th flight for the Dragon capsule Resilience. Splashdown in the Pacific Ocean off the coast of Oceanside, California, took place 3.5 days after the launch, the spacecraft having orbited the poles 55 times, an average altitude of 437 kilometers.
And we are still currently in the blackout comms period, but we are expecting to come out of that any minute now. The recovery ship Shannon patiently waiting, as well as a couple fast boats there, part of the recovery team. They'll first meet Dragon once it splashes down, make sure that the vehicle is safe, and then begin the recovery operations.
We have 2 sets of parachutes on board Dragon during reentry. The first are the drogues. We're standing by for that drogue chute deploy. That will happen when Dragon is moving at about 350 miles per hour.
Dragon, SpaceX, comm check.
SpaceX Dragon, we have you loud and clear.
We have you the same. We see a healthy flight computer. Expect automated chute deployment.
Dragon, copy.
A GPS has converged. Expect nominal altitude for drogue chute deploy.
Dragon, copy.
We have confirmation that we have come out of the blackout period and established comms back with the From-2 crew as they're making their way back down to Earth.
So again, those drogue chutes are special in that they are smaller and lighter than our main.
Brace for drogues.
Good copy. Brace for drogue.
The seats are rotating in preparation for splashdown, and the crew is bracing for the drogue parachutes. They're going to feel maybe a little bit of a jolt as the vehicle is going to slow down very quickly.
Just ahead of the call out for drogue chute deployment, Dragon will autonomously safe the propulsion system on board and then deploy those drogue parachutes.
Visual on 2 healthy drogues.
Copy. We see the same. 2 healthy drogues. SpaceX Dragon, crew brace for mains.
Copy. Brace for main.
We are expecting the main parachutes to deploy.
Drogue chutes are doing that initial slowdown.
We see visual on 4 healthy mains.
SpaceX Dragon, we see the same. 4 healthy mains.
The main parachutes have deployed. They are expanding. Once they're fully expanded, they are going to slow the vehicle down all the way to about 16 miles per hour. Right in time for splashing down into the Pacific Ocean today.
Right now, Dragon has saved all propulsion systems on board.
1,000.
Copy. 1,000 meters.
Dragon right now is also terminating the nitrox suit and cabin purges and is beginning to increase pressure in preparation for landing.
And additionally, the mission control team here in Hawthorne is reporting the precise landing coordinates to the recovery team so that they know exactly where
800.
Where the
copy 800
exactly where they're expected to touch down. And you are hearing those call outs. We are confirming the altitude as the vehicle makes its way back down to Earth.
Our next major milestone is splashdown.
200.
Copy 200 meters and braced for splashdown.
Inside of that Dragon capsule are the 4 From-2 crew members. Welcome home, From-2. We have confirmation of splashdown of the Dragon spacecraft. Dragon has returned home with the From-2 crew.
The Fram-2 mission is named in honour of the Norwegian polar research vessel Fram. It undertook 3 expeditions to the Arctic Ocean ice floes between 1893 and 1896, to the Arctic archipelago west of Greenland between 1898 and 1902, and to the Antarctic between 1910 and 1912. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study warns that agriculture could push antibiotic use in livestock by a further 29% over the next 15 years. The findings, reported in the journal Nature Communications, come despite widespread knowledge that the overuse of antibiotics poses a significant health danger for the spread of more resistant bacterial strains, the so-called superbugs. The authors say increases in demand for animal products as human populations grow means global livestock numbers are likely to increase in the coming decades, and that could lead to more antibiotics in total being used on livestock. They modelled various scenarios and say that a business-as-usual approach to antibiotic use on farms would lead to a 29% increase in antibiotic use by 2040 as livestock numbers increase. Antibiotics are commonly used in livestock, not for health reasons, but to increase body mass. A new study warns that seabirds mistakenly eating plastic thinking it's food are suffering failing organs, brain and nerve problems, as well as cell damage. A report in the journal Science Advances found that plastic pollution ingested by seabirds can not only cause malnutrition, but also lead to cell damage, organ dysfunction and neurological decline. The authors reached their conclusions after studying young sable shearwaters that appeared to be outwardly healthy. But they found even small amounts of plastic ingested by the seabirds showed clear signs of cell damage, organ dysfunction, and even signs of neurodegeneration. A new study warns that teen girls who spend longer on their phones are more likely to have both less sleep and lower sleep quality. The findings, reported in the journal PLOS Global Public Health, suggest the link increases the risk of symptoms of depression. The study tracked the screen time, sleep and mental health of 4,810 Swedish teenagers aged between 12 and 16 over a 12-month period. They found that increased screen time led to worse sleep within 3 months. Now for boys, the authors found increased screen time was directly linked to high depressive symptoms over the year, whereas for girls, they say about half the link between screen time and depression could be explained by poorer sleep duration and poorer sleep quality. Japanese video game giant Nintendo has released details about its new Switch 2 console, announcing an update for the hugely successful 2017 original that's already sold over 150 million units. What's new is a C button that activates game chat, allowing users to speak with one another during playing. Its controllers, which attach with magnets, can also be used like a desktop computer mouse. And its game share function enables players to share games with friends and temporarily play together. With the details, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.life.
G'day, Stuart. Yes, well, the new Nintendo Switch 2 has been long awaited, and it has come out with nicely upgraded specs, the sort of specs you'd expect to see in a second-generation device. So the original one was 6.2 inches, an LCD screen with basically 720p resolution. There was a second generation, the Switch OLED, about 4 or 5 years ago, and that had a larger 7-inch display, but the Switch 2 bumps this up to a 7.9-inch display, 1080p, and it's using a 120 hertz refresh rate. Now, it's LCD, not OLED, and that's probably to lower the costs, but we have a faster ARM processor, better graphics, as you would imagine, and this is the ultimate portable gaming device. Sony gave up on its PlayStation Portable and its PS Vita some years back. I still have a PS Vita, but, and it was a cool device, still looks very cool to this day, but it didn't have the longevity that Nintendo has had in the handheld gaming space, right back to those original Donkey Kong Game & Watch devices, which I still have at home and sell for crazy prices on eBay. And then, of course, the Game Boy in black and white. I remember that fondly with the Tetris game. It was a huge hit. We had all sorts of variations with color screens, the Nintendo 3DS, and the 3D craze was quite popular on Nintendo. It was more about depth rather than things popping out of the screen. And then the Switch 1 and the Switch 2, which have really taken the gaming world by storm and should sell in the hundreds of millions once again.
And what about price? How do they compare?
In the US, it's $449 for the Nintendo Switch and $500 including the new Mario Kart game. In Australian dollars, it's about $700 for the unit itself and $780 Australian with the game. So, a bit more expensive, but this is a premium device. It'll give you much more satisfying gaming experience than using an iPad, even an iPad mini or an Android tablet of a similar size, because this is really designed for gaming with the Joy-Cons that are easy to use. You can use it in desktop mode with a dock plugged into the TV. You can use it on the go. You can do those things with an iPad as well, but Nintendo just has especially a whole stack of really valuable IP, all the Mario games, Mario Kart, which is the big popular driving game that everyone loves to play. And I think if the kids of 1985 looking, whenever it was, looking at that Game Boy Color thought what it might be in the future, they probably didn't think it would be anywhere near as good as it is. And it's going to go on sale June 5th, and it'll be a global hit, and there'll be a lot of pester power from kids wanting their parents to buy them one as soon as they can.
That's Alex Zaharov-Reutt from TechAdvice.life. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from SpaceTimeWithStuartGarry.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to SpaceTimeWithStuartGarry.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.